Going?
Yeah.
Okay. We're on derivatives. Here's my definition of a derivative. This is my own words. Figure you'll like it better than what the book says. Tell me if this sounds familiar. Isn't that what we just did? Yes, yes, it is. It is exactly what we just did. The derivative of a function is the limit as h approaches 0 of f of x plus h minus f of x over h. It is that. That is the derivative of a function. So really this is not new, is it?
No.
But there's ways to write derivatives. So yeah, the derivative is just the slope of the tangent line at a point. Most of the ones we do though, we're going to do, let's just do an example, like, I don't know, let's say we have f of x equals, x squared minus 2x plus 5, I don't know. On the one we did before, I told you the point to find the slope at, right? I would say find the slope at x equals whatever, and you would do it, right? Well, in this, we're not necessarily going to do that. We're going to just say find the derivative of that, meaning find the derivative at any point. So now instead of,
So we can choose any point?
no, you're just going to use x.
Oh.
Instead of 4 or 5 or 6, you just use x, and you're going to have a whole bunch of letters. So you're, yeah. So you're kind of using this. So like you're changing y over changing x now. It's going to be a little different. Your 2 points you're going to use x, y, and x plus h. Well, I guess not really y. It's just x and x plus h. It's just this. It's this. Okay? X plus h, plug it in, work it all out. It's doing the same exact thing, but now instead of 4 plus h or 5 plus h, you're using x plus h. You know what I mean? So if we were to do this, f of x plus h, that would be x plus h squared minus 2 times x plus h plus 5. Right?
Yeah. Minus the
Minus the original. Notice I put parentheses. All over. And this, you know why there's just h on the bottom? Because did you notice what happened every single time you would do it?
It would just stay.
Yeah, you would just end up with an h. You'd have like 4 plus h minus 4, or you'd have 5, you know. That would always happen. So it's just over h. What else is going to always happen? When you work this stuff out on the top,
And it's always like minus like 16, and it's like it always comes
the
out.
constant always goes away.
Yeah.
Everything will have an h in it at the end, won't it?
Yeah.
Okay. So let's do it real quick. You fast yet? You know what x plus h squared is? Can you do that in your head fast? Close.
H squared plus 2x
hx
plus hx.
minus 2x minus 2h plus 5 and minus. Remember to minus all of these. Minus x squared plus
2x.
totally just screwed me up.
2x minus 5. I just wrote them all over the place. Crazy like that. So x squared and x squared are gone. Negative 2x and 2x, 5, 5. Should get 2hx plus h squared minus 2h.
Over h.
So divide an h out. Am I going too fast?
A little.
Little? You're writing too much.
I don't know how much you're right.
Just divide the h out and what? 2x plus h
Minus two.
Minus
minus
2.
2. 2x plus h minus 2. And then, is that it? What is that?
That's your,
Factor
what you use to find the limit.
Yeah, that's this simplified, isn't it?
Yeah.
So what do we still have to do?
The limit.
The limit.
Limit as h approaches 0.
Of 2x plus.
How do you do the limit as h approaches 0 of that?
Plug in.
Plug in 0 for
Zero.
h.
What about the x?
Yeah,
Approaches 0. And so what is your answer?
2x minus
2x
2.
minus 2.
You know, this is weird. That is the slope of this. That is the slope of that, depending on where x is. If I pick x is 5, the slope at x equals 5 would be 8. 10 minus 2 is 8.
Oh.
If I pick x as 7, like this is just the general way of doing it. We just did it with x's and h's, right? If I
Yeah.
said find the slope of that when x is 2, you would just go, oh, 2 times 2 is 4, 4 minus, oh, the slope is 2 at that point. That is the derivative of that. There's different ways of writing it. You could write that. It's like a little parenthesis right there.
Does that just mean derivative?
That means the derivative of that. The way you read that is f prime of x. That's how you read that.
That's fancy.
Yeah. There's a bunch of different ways of
Wait,
writing this.
that would be the answer?
Yeah.
That one?
That's one way of writing your answer. There's a whole bunch of different ways of writing derivative. You could write f prime of x. These all mean derivative. You could write dy over dx. That's the weirdest one. D kind of just means, I don't know, it explains where that came from. I think D like means difference. Or this derivative of y with respect to x. It all means slope, change in y over change in x kind of, right?
Yeah.
You could write d over dx of f of x. There's just different ways of writing the same thing.
I like the first one.
Yeah.
The first one is, yeah, definitely the nice.
Yeah.
You could write, if that said y equals, you could write y prime. They all just mean derivative. So that'll just be like, you'll notice them throughout, and we'll just mention them like, oh, that's just a way of writing the derivative. It's just another way. Okay. Yeah.
Is that all for today?
Yeah, just finding derivatives. And it's just stuff you've already done.
Should I just leave homework?
I'm going to do one more example so that, you know.
You seriously have to give me a notebook already, yeah? 4 pages left.
Okay.
There is an alternate definition of a derivative, a different definition. You could do, I don't like this because I don't know if you want to memorize this.
Do you think so?
If they say to do it at point A, so to find the derivative, I don't know how to put a T. Find the derivative at x equals A. You could do f prime of A equals limit as x approaches A of f of x minus f of A over x minus A. That's just slope at a point. What's this mean?
The original.
That's the original function, right?
Yeah.
What's this?
Plugging
The
A.
value of the function at that point. So isn't this just like changing y? From the original to your point? Right? That's just a y value.
It's like when
What?
when you're giving us a number, it's just with the letter now, right?
I said f of x equals 2x to the third plus, I don't know, 4x. Oh, I don't. Let's say that's not, let's just do it. Add x equals, pick a number.
2.
2. Okay, so the derivative at the point 2. The way you would write that, f prime of 2. Right, because there's your original function. This is the derivative of your original function at the point x equals 2. Does that make sense? Equals, then you could just use this. So you do the limit as x approaches 2. What's f of x? What's that?
The original.
The original. So you're going to go 2x to the third plus 4x minus
And then A.
f of a. What is that?
So 2A.
2. It's just plugging 2 in to the equation, right? It's
Oh.
the value, in this case, x equals 2. So this is f of a would be f of 2, which is the value of the function when x equals 2, right? So you plug 2 in. I'm going to put brackets here so I can 2 times 2 to the third plus 4 times 2. Or you could use our old slope way if you don't like this. I don't like memorizing formulas. Remember how we used to do it? We would just say change in y over change in x. In this case though, your 2 points, one of them is x, comma, what would be the y value? If I plug in x for x, 2x to the third plus 4x. Right?
Yeah.
Your other point is 2, comma, plug it in, 2 to the third is 8, 16 plus 8 is 24. Those are your 2 points. Didn't we just do change in y?
So the
This
first-
minus this over x minus 2, isn't that all it is?
Yeah.
Yeah.
Just change in y over change in x.
So the first point is always going to be the
It's just
x
x,
and the
yeah.
equation problem.
The only difference here is one of your points is just x. So then you just work out all that fun stuff. I think I just said that's 24, right?
Yeah.
2x to the third plus 4x plus 24 over x minus 2. Uh-oh.
Wouldn't it be negative
It's
24?
minus 24.
Is it mine? Oh, yeah.
Yeah.
Uh-oh. What happened?
The 24 is still in there.
Things don't really cancel out.
Things are going to cancel out today.
No.
That's unfortunate. I'm thinking. I don't know the answer to why that anymore. That's why I told you I don't like formulas. Reduce by. Come here. Put 2 out. That still won't be factorable, will it?
Nope.
It's x to the third. The limit does not exist. This is just how I did it.
Would your original one need a number in there?
My original, what, here?
Yeah.
You know what we should have done? Start trying to use this. What's a better way?
You never teach the better way the first time.
Yeah, I did. We did. I told you the better way.
Change of x over change
I
of
tried to
y.
do it without formulas because I was just trying to show you the only good way. So if we scrap this, which means we scrap this, what would your 2 points you would use? If I just gave you that, and said find the slope at x equals 2, what would you do?
2, plug in
2, comma.
2 and 2 on a4, and what would your other one be?
And then
2
2 plus,
plus
h.
and then
2 plus
plug it
h
into
squared.
the-
We should have just done that. So
Yeah.
screw the formulas. Let's, yeah, it's stupid. guarantee that's factorable somehow and we can figure it out, but ain't nobody got time for that. You know what else no one has time to do? That problem. Because you know how to do it, right? It's the same thing as we did before. You know you're gonna multiply that whole crappy thing out. Well, 2 times that plus 4 times 2 plus.
It's cubed or squared?
I did cubed, I shouldn't have.
Oh,
So that's gonna take too long.
oh,
Don't use,
But we get it.
okay.
yeah, it's
It's-
all the same
yeah.
thing. Don't use the formula. Because it says in exercises 5 through 8, use the definition to find the derivative of the function at a given value of a. Don't do that. Don't use that formula. Just use what you already know now, because it's the same thing. The derivative just means the slope at that point. Okay? Sorry for
The extra 5 minutes.
the extra 5 minutes of your life that you're never going to get back. Yeah, it says use the no. Quick review 1 and 5. Are good. Especially number 1, because you're not supposed to use a calculator.
Oh, that's that? Which one, the one out?
And then 3, 4, 6, 7, 12
I go home eagerly and look at them.
are just finding the slopes at given points.
Did I show you that?
I wanted to do it however you know how to do it. Don't necessarily, because look, it tells you,
I like the weather that's here. Will you do it?
it tells you use this definition to do it. Well, I disagree. Use whatever definition you want. Use change in y over change in x and make up your own. I mean, that's the one we usually did, but. Yeah, use this definition. No, these are all the same thing.
We just do it the way you told us, like, you know.
What did I just say? 3, 4, 6, 7, 12. Yeah, these are all pretty. Well, the hardest one's 12. Look at 12.
It says just find the derivative if
F of x equals 3x squared.
Squared.
So it's not saying add a point.
So you have to do it the other way then, huh?
You have to do
To show her.
this pretty much. Your 2 points are x. Here, I'll give it to you. For 12. This is fine.
Can I write that differently?
No.
You can't get the write it down?
Yes. Get used, just get used to all the different ways of writing. Find the derivative of fx. Okay, so what are your 2 points? What do you think, Katie? X. And then what would the y value of that be?
3x squared.
3x squared. Okay, what's your second point?
So good.
Okay, Brandon, you're so good. What's the second point?
Okay, I don't know, honestly don't know. It's the fine.
X plus H.
X plus h.
Yeah, that.
And then 3x plus h
X plus H
squared. Change in y over change in x. Limit as h approaches 0. Easy deal, right?
Yeah.
Okay. They're all the other ones have a number. So you're just going to do your 1. It's just it's basically more practice of what we just did on your test. That's basically what it is. But now it's just
Is
a
it number
different way of
12?
writing it in a
Yeah.
new word. It's called the derivative. Yeah.